Thank you. Thank you. Good afternoon. Okay, thank you. All right. My name is Arun Gupta, and I work for Oracle. And I'm here to talk about the Java EE 7 platform. How many of you, by a show of hands, use J2EE, Java EE in your daily life? Wow, excellent. 90% of you. Well, pretty much only a handful or maybe .NET developers here. This is a standard Oracle disclaimer that we have, means all the dates are indicative, not definitive, and can change last minute. You can sue me or Oracle for that. But now onwards, it's all a developer talk. Okay, Java EE 6 platform was announced in December of 2009. So over 3 years ago, we have seen huge uptake with the platform on how it looks like. There have been Glassfish is the reference implementation of the Java EE platform. Not only that, but just Glassfish itself, we have seen 50 million plus downloads. Only Glassfish. I'm not even talking about any of the JBosses and WebLogics and WebSpheres, any of those. I'm not talking about any of those. So it's been the most widely adopted, I would say, application server or the platform for us. There are 18 compliant application servers. So you can see there's a good choice that is available to you. The true benefit of using Java EE APIs is you build your applications once using those API, and it gives you the ability to port across multiple app servers. Of course, if you choose app server specific API, then you get stuck, but that's the whole promise otherwise. Just a quick recap in terms of the top 10 features that I think are important for Java EE 6. I personally like how people associate lightweight developer productivity with the Java EE 6 platform. And we did most of the efforts in the platform around that area. For example, EJBs are now a single POJO with a single annotation, and they can be packaged in a WAR file. Very simple, okay? You get all of your transactional semantics, etc. with that. We have the inbuilt support for dependency injection in the platform. You no longer need to rely upon third-party proprietary closed source frameworks. You want to look at, okay, I want dependency injection in the platform. I don't want to blow up my WAR file. I'm going to use the CDI or context and dependency injection that is part of the platform itself. A lot more annotations, a lot more POJO-driven development, what I call as PDD. We have JSF standardizing on facelets, truly enabling your MVC-based architecture. You can write your views purely using XHTML and CSS, and just putting exactly your views and models and controllers in the corresponding beans. So like models would be your JPA entities, controllers could be your EJBs or servlets or whatever you care, okay? So there were a lot of big improvements that were made as part of the Java EE 6 platform, but having said that, we're here to talk about Java EE 7. What is it that we're doing as part of Java EE 7? There are two big themes, the first one being developer productivity. What are we doing for developer productivity over there? We are focusing a lot more on making you write less boilerplate code. So think about how much code you need to write if you have to send a simple JMS message. Anybody feel the pain? Yeah, so that's sort of the response that I see. I mean, it's painful to send a simple JMS message. We are heavily using dependency injection so that we can get rid of the boilerplate code, and I'll show you samples of that. A lot more POJOs are being added to the platform. You just add a single annotation on a POJO, and that makes it much more comfortable for you to enable the functionality, just simple POJO. A lot more richer functionality as part of the platform itself. So things like, how do you do batch processing today? You have to, again, incorporate third-party frameworks. We're adding batch to the Java EE 7 platform itself. You can use inbuilt platform functionality. A lot more defaults as well. For example, when you're writing a Java EE application, you want to write a database-driven application. If you're doing a database-driven application, what do you need? You need a JDBC resource. Well, if I have to use a JDBC resource, why should I create one? So the platform is now providing you a default JDBC resource. It is giving you a default JMS connection factory and things like that. The idea is to provide a lot more seamless user experience so that the applications are ready out of the box. You don't have to depend upon, oh, I want to do a rapid prototyping, but as part of that, I need to understand how do I create a JDBC resource. Now, those are the features that we're doing around developer productivity. In terms of HTML5, which is our, again, the other big theme, we are giving you support for first-class WebSocket-driven development. And I'll show you some samples around that. We're also adding the ability to do Json processing. Once again, today you're using third-party libraries to doing Json processing. This will actually get rid of those dependency because it's going to be baked into the platform itself. In JSF as well, we are allowing you, typically or traditionally in JSF, any attribute that goes on your tag needs to be understood by the backing component or the renderer. Otherwise, it's ignored, and it's not sent to the front end. So we are allowing, with HTML5 specifically, you can specify data star attributes, or you can say what is the type of an attribute, or what is the type of an input element, like is it telephone, is it fax, is it email, and things like that. We are enabling those attributes very easily. Okay. So those are sort of my big themes here for Java E7, developer productivity and HTML5. Given that background, I'm going to double click on each of these themes and talk about the different specifications in the landscape. Let's take a look at the different JSRs that are part of the Java E7 platform. Now on the bottom, what you see is sort of what I call as a plumbing layer. So Java Persistence API, for database communication, JMS for all my messaging, JCA for connecting to my legacy systems, batch for all my batch processing. Okay, that's sort of what I call as the bottom tier or the backend tier. Then in the middle tier, if I were to show you the classification, in the middle tier I have my EJBs, my managed beans are there. Of course, I have my CDI beans. We are enabling so that you can make any POJO as a transactional object. We are extracting the transactional semantics out of EJB. By extracting, I don't mean cutting out of it. We're still keeping EJBs transactional, but ability to make a POJO as a transactional is also available now. And we'll talk about that. That's what my interceptors and JTA come in. Concurrency is a new functionality that is being added to the platform, which allows you to run managed threads or run your tasks in managed threads. And we'll talk about all of that. That's sort of my middle tier. And then finally, I have my web tier, where, of course, my traditional or classic servlet is there. And in addition, I have my JSF, JSP, JSON, WebSocket, all those technologies are in there. Now the 4 new technologies are highlighted in orange. So JSON, WebSocket, Concurrency, and Batch. Those 4 new technologies have been added to the platform in this release. Several other technologies got major updates, and that's worth noticing. And then on the far right, what you see is bean validation. That is more widespread across the platform. So for example, I could specify validation constraint on my JPA entity that will be honored when the entity is persisted, updated, or deleted. I could specify my bean validation constraint on my Jax-Rs resources. So whenever I'm trying to invoke a REST endpoint, say getting or putting or posting, those constraints will be automatically validated. All of these specifications, by the way, are now final. And what I mean by final is that the specifications are done, and that was done like about 10 days back. So within the next 4 days, by the rule, we are required to have all the implementations final as well. That means all the features that I'm going to talk about today, they are done in terms of implementation, and they are getting released now in the next 4 days or so. All of these features are, of course, they're part of Java E7, so they're integrated in Java E7 or the reference implementation of Java E7, which is Glassfish. So Glassfish is the reference implementation. All these features are available today as part of Glassfish. Let's take a look at our very first API, which is Java API for WebSocket. What does it give me? Well, it gives me a standard way of building WebSocket-driven applications. What are the WebSockets good for? Well, WebSocket is a bidirectional, full duplex communication channel. So unlike HTTP, where you create a HTTP connection, do a request response, and you close the connection and you close the TCP and everything goes away. WebSockets are bidirectional. It's client to server, server to client, not just client to server like unlike HTTP. It's over a single TCP connection. So once the connection is established, it's a peer-to-peer protocol. Client can send message, server can send message to client. All of that is possible. So we are enabling that functionality as part of Java EE 7. If you want to build such an application, then there are two ways to do that. You can do annotated endpoint, where you take a POJO, on the POJO you put an annotation, and that becomes a WebSocket endpoint. Or you can say, I want to make a programmatic endpoint, where I'm going to extend or implement an interface. Both the approaches are possible, and we'll talk about that. Now, I said it's a peer-to-peer protocol, so there's a concept of a server endpoint, and then there's a concept of a client endpoint. So we have annotations and approach by which we can do both of those. Okay, so I'll talk about that. Now, in addition to that, we also have this concept of life cycle callbacks. When is the connection open? When is the connection closed? If there's an error, how do I handle that? Things like that. Okay, and then of course we talk about packaging and deployment. Okay, so these are the different concepts of Java API for WebSocket. I'll show you a quick demo, and hopefully that will clean up things. This is a very trivial sample where I talk about how a WebSocket endpoint is developed and deployed. Take a look at the black part of the code. I have a public class hello bean. It's a method which says public, returns type string. The method name is say hello. It takes a parameter. And the response is return hello plus name. Very simple, right? Nothing fancy there. How do I make it a WebSocket endpoint? I just add the annotation add server endpoint. And the moment I say add server endpoint, I need to specify the URI where the endpoint is listening. So that's the URI, which is /hello in my case. Now this is a WebSocket endpoint. For a WebSocket endpoint, when the message is received, I want to dispatch that to a business method. How do I dispatch that to a business method? I specify the annotation @onMessage. That means anytime a message is being received by hello bean, call the method say hello. And what happens then? Okay, well, I call the method say hello. The WebSocket payload is automatically mapped to the method parameter, which is string name in this case. So if it's a text message, it gets mapped to the name parameter. Now in WebSocket, it could be either a string message or a binary message. So you can do binary as well. For example, you can change string type to byte array or byte buffer, and then you can receive binary payloads. So all of that data formatting is possible, or reception is possible. Now think about string as a return type. The method looks pretty simple, and it is simple. But WebSocket, as I said, is a very low-level protocol. There is no concept of request response in WebSocket. Everything has to be built by your application. And this is how I'm building request response. So what I'm saying here is my request is mapped to the string parameter. My response is mapped to the string return value. So effectively, my request, my message from client to server is a request, and my message from server to client is a response. And these are two one-way messages. The correlation needs to happen at your application layer here. Okay, it's a very trivial chat application, and you can see I'm graphically challenged. It still shows you the concepts of Java EE 7. So I'm going to keep this open in a Chrome browser, and I'm going to have a Firefox browser. Open the URL here. Okay, so these are my two browser windows. I say Duke, you're going to join the chat. Duke joins the chat. As soon as the Duke username shows up here, it automatically appears on the other browser as well. Now on this browser, I could say Duke2 joins the chat. So this chat list is updated, and so is this chat list. Okay. Now in here, when we are chatting, so Duke2 is going to send a message, say hello, and I say chat. So the message shows up here, say Duke:hello, and in the same chat log, same thing here. I could say howdy, and I can say chat. The message appears. Okay, so nothing fancy, very typical chat application, but this is one-to-one. Let's take a look at the code behind this to understand what's happening. Oh, you can't read the source code. Okay. chat endpoint. It says public class chat endpoint. How do I make it a server endpoint? Well, it's a server side, so I'm going to add the server endpoint annotation on line 56. Then I'm maintaining a set of session, and that set of session object is encapsulation of the client that is trying to connect with the server. That's the encapsulation basically. I'm creating a set. I have my callback handlers on line 60 here. I'm saying every time a connection is open to this chat endpoint, call this business method because this annotation exists. I'm going to add it to the peers. If the connection is closed, I'm going to remove it from the peers. So at any given point of time, I have a list of clients that are connected to me. And how do I broadcast the message? Simple as this. I just say at on message on my business method here. In here, if you know, this is my endpoint, or this is my payload of the WebSocket. This shows the client that is making the request. If I want to broadcast a message to all the clients, all I say is iterate over the set, get the remote object of the client, and send a message. As simple as that. Now, any application logic wherein if it is directed to a user, or you want to append some text messages or timestamp, all of that, that goes in this message method. The name of the method does not matter. It's the annotation on the method that matters. Okay. Another API, another new API that we have added to the platform is Java API for Json processing. Now, Json is a lingua franca of the web. People use that all the time for simple web applications. If you're familiar with the XML LAN in Java, there's an API called as Jax-P, or Java API for XML processing. Similarly, there's an API called as Jax-B, which is Java API for XML binding. Now, XML processing is a much lower level API, where you can do stream handling, DOM API, and things like that. Jax-B is a higher level API, where you can say, oh, take a Java object, bind it to a corresponding XML, and automatically do marshalling and unmarshalling for me. This API, Java API for JSON processing, is like Jax-P. The binding API, where you take an object and say, convert it, automatically map it to JSON back and forth, that's coming in the future release. Another analogy. Now, in Jax-P, as we talked about, there's a streaming API and a DOM API. We have that concept here too. So, for example, here, we have a streaming API and object model API. The streaming API by itself is a much lower level API. It can generate events for you. What kind of events? Well, events is, for example, the JSON structure is a name value pair, right? It can generate events like start of a name, start of a value, or start of an array, things like that. So those are my standard events that I look at and I generate those events. Okay. And then it also allows pluggability with other parsers. So if you're using an existing parser that you're happy with in terms of performance, you can plug your parser in the API. There's a pluggable mechanism for that. The object model API builds on top of streaming API. It's a higher level API, but it says, oh, you know what? I know this is a JSON structure. I don't care about the events. I want to read the whole thing. Give me a JSON object. And then I'm going to use my Java APIs on the JSON object to get the values that I care about. So you have a streaming API and a DOM API, and both of those, the DOM API work on top of the streaming API. I can get a JSON parser here. Then on the parser, I can say, give me an iterator of the events, and I'm going to iterate through the events. The very first one that I say is start object, which is right over here. So it says I'm object starting. Then I say, give me the next object. So it says start of a key name. Then I say next event. So I say start of a value. And then at that point of time, when I say parser.getString, it gives me the entire string value. So at this point of time, when I say parser.getString in the last line, it's going to give me the value John. Another new API that we are adding to the platform is batch applications for the Java platform. Now, most of you guys are probably familiar with the batch concept. It's typically suited for non-interactive, bulk-oriented tasks. I want to generate an email statement. If I want to generate an email statement, I don't want to do that on Tuesday morning, 11 o'clock. That's the peak time of my traffic. That's where customers are in there, they're angry, I don't want to slow down my system in any sense. So what you do is on Sunday morning 2 a.m. when hopefully the traffic is low or minimal, you say, okay, I'm going to schedule it around that time. What would a bank email statement generation step take? Well, it would take read an account from a database. Once you read an account, you want to process the data account, or you want to process the account. Processing would mean look at the account, figure out, issue a query against the account from this date to this date, calculate the balance, address, etc., extract the email ID, and then you have to send an email ID. So the processing part is generating the email statement, and then there is a actual email sending part of it. So in terms of batch, what we say is defined as a chunk. And that's how the design pattern says. So a chunk really has three concepts: a reader, a writer, a processor, and a writer. Reader being reading from the account, processor being processing the account, generating the email statement, and a writer being sending the email statement. Those are my three big concepts over there. Now, the broader concepts of batch are, well, you have the job, you want to run it parallelly. So you may want to run it in different partitions, for example. You can say, oh, I have 100,000 records to process. I'm going to process my first 10,000 records on one thread, next 10,000 records on second thread. I have like a 16-core machine. I can run up to 16 threads. I will let it run. So you can do all that kind of partitioning very easily. All those concepts are available in the batch applications. Talking a little bit more about the batch applications itself, we talked about how a job is the concept, is a very high-level concept. So I have a concept of a job, my job being sending email statement. A job could have multiple steps. A step, as I said, has a reader, processor, and writer. Now you have to kickstart the job, and that's where the job operator comes in handy. It says, okay, I'm going to take a look at the job, you're going to give me the job, and I'm going to issue a command to execute the job, and I'll do all the reader, writer, processor, etc. And then, of course, we have a job repository here where all my jobs are stored. The job operator picks up a job from the repository. You have a job has a step has a reader, processor, writer, and you issue the query or issue the command to execute the job. Job is described using a job XML. So I have this concept of a job XML. Now each job, as we said, has a step. The step in terms has a logical name. In this case, the logical name is send statements. And a step in this case is of the type chunk, which is identified by the element chunk here. So when I say chunk, now a chunk can have a reader, processor, and a writer. In this case, I'm saying reader is account reader. What the account reader really means is, this is a reference to a CDI bean, to a bean that is injectable in my job XML. And we'll talk about it in a second. Similarly, processor is saying account processor, injectable bean in the job XML. Writer ref, injectable bean in the job XML. And then I have a chunk size. So what I'm saying here is, I'm going to read an account, and I'm going to process the account, and aggregate it to the writer. And then I'm going to read it and write it, read it and process it and give it to writer. So I'm going to read and process 10 accounts. They're going to be aggregated with the writer. When 10 are done, then I'm going to issue a write command, which in this case could be sending an email statement. Okay? All of this step, so reading, processing, chunk number of times, and writing is all done within a transaction boundary. Item reader interface. It has a simple method called as read item, which returns an object. So we are reading an object using JPA, like a database query. Then I have an item processor, which is likely taking an account object, which is my parameter, and then from that account object, I'm generating an email statement, okay, which is again of the type object. Finally, I have an item writer, which is where all the email statements are aggregated, and you have to do nothing on that. That aggregation, etc., is automatically handled by the batch runtime. So all my aggregation happens here in the list, and this is where I use Java mail to send email. All of that automatically done in the Java EE stack for you. Reader Well, the earlier version really had it using generics, which made it much more clear. But because of some issues with CDI and batch, that was moved out pretty much at the last minute. So just to make it clear now, reader has an object here. Okay, this is the object that I read, which is my account object. Let me show you a code since you asked it. Let me show you a real code here. Step as a chunk, reader, processor, writer. Now the processor could be completely optional. I may not be processing the record as is. Maybe I'm just taking the record from CSV and dumping it as it is into the database. It has already been validated. Typically processor is where I'll do the validation. But in this case, let's say we have a processor, abstract item reader, and in this case I'm saying, oh, this is a CDI bean. I mark it as @name, so it's injectable in my job XML, which is my job description. Here I have a method called as open, where I'm going to initialize my resources. In this case, I'm just making it completely local. I'm using string tokenizer, but this is where I will read the value from a reader or a stream or some other source. I'm going to get the value here, and then here I'm going to say I'm going to read an item. And now remember, this is returning a my input record. My input record in this case is very trivial, just has an int. So I just read from the string token, put it into the my input record. Now here all I'm saying is, if token has more token, return my input record. So whatever reader returns, if there is a processor, it goes to the processor. That is the parameter of the processor. Okay, so let's take a look at my item processor then. My item processor, again, very trivial. My input record comes here as this parameter. It comes over here. In this method, I'm saying, okay, input record, give me your ID. If you are an even number, I'm going to dump you. I'm going to return null. When I return null, nothing goes to my writer for aggregation. And if there is a valid ID, I'm going to generate a my input output record. That's what I'm returning over here. My output record is the one that goes to the writer for aggregation automatically. So think of this not as a list, but think of it as a list of my output record. And that aggregation is handled by the batch runtime for you. Now in my item writer, output record. And when I say write items, if I run it this basically, this is about the job metadata, but let's see the real result, which is down in the log here. So what we're saying is, my input record 1, 2, 3. In write items, all I'm seeing is 2 and 6, because record number 2 being %2 equals 0 is rejected, returning null. So that is not aggregated to the writer. So this aggregation happens automatically by the batch runtime. Now this is a 1-hour presentation about the broader Java EE 7 platform. We can pretty much do an hour-long presentation on each topic. But just to answer your short question, yes, it has decisions, flows, splits, all of that support is available. There is a concept of ignore this exception, or after step, before step, listeners, all those concepts are available.
Even transaction management, it's all like container maintained, or like?
This is all container managed. You can do user managed as well. Yeah. By default, if you're doing chunk, this is container managed.
So you don't have to configure anything?
No. Yeah. By default, it is. So I showed you my code, for example, here.
That's what I was wondering.
No, there's nothing at all. There's nothing at all over there. For the chunk, like if my chunk items or chunk count or item count is 10, which is the default, for those 10 items, either the whole thing is automatically done, like read, process, write, all is done together, or is committed or rollback. And there are checkpointing mechanisms as well.
Are there default implementation for like readers, like for connecting to Hibernate or Kubernetes, or if some databases are there?
No, well, no, not really, because these are all interfaces. When you implement it in the open method, as I was showing, you will say, okay, I'm going to connect to whatever database it is. And that's pretty trivial, because all you need is a persistence.xml in there, specifying your persistence provider to your JDBC resource, which is connecting to your Hibernate. And that's just standard routine. Yeah, because see, the specs are more generic. They provide a framework, or they provide, our underlying platform on which you build what your application needs to do. A new specification that is added. Question? I'm not fully familiar with the APIs of Quartz scheduler per se, but I told you gave you a quick overview of what the batch API can really do. This is more as a replacement of Spring Batch, for example. So I don't know if Spring Batch can replace Quartz scheduler. So think in those terms. One of the features in part of Java EE 6, for example, EJB has add schedule annotation. Add schedule lets you do, for example, cron-based timers. So maybe, depending upon what abilities you're looking for, I would say explore these two areas. A new functionality added to the platform is concurrency utilities for Java EE. Now, traditionally, or by design, in Java EE is not recommended and even allowed in certain cases to spin up your new threads. Why? Because Java EE is a managed environment. If you spin up your own threads, that's not a managed thread, that's a user managed thread. So there is no such concept of a user managed thread in Java EE, because then the container, well, there's a reason for that. The container does not know how you're going to manage the thread, and if it needs to pass the JNDI class naming context or the class loading context or security context, it cannot do that because you are managing it. So that's why it was restricted and not permitted in a common case. With concurrency utilities, we are leveraging JDK concurrency utilities, which is JSR 166Y. We are leveraging those principles, so like executor service, concurrency, executor service, schedule executor service, all of those. And we are providing a managed version of that. Okay. The idea is we provide, yes ma'am, manage objects. In JDK, if you want to create your own thread pool, you say executor service, and then you say I'm going to have my runnable task, my callable task. These are my tasks. These are not container tasks. These are my user application tasks, and I want to run them, concurrently. I could say invoke all. So for example, I create an executor pool service, and I have 10 threads over there waiting for my user task to be done, and I can say invoke all, or I can say, oh, I don't care, invoke any. So just one thread will execute automatically. Very simplified semantics. So we're leveraging all of those design patterns and enabling them in the Java EE environment. All the context propagation, which is JNDI, class naming, security, etc., is automatically propagated. The transaction context you have to explicitly propagate, because that syntax or semantics is not propagated automatically. You also have task event notifications. Oh, when is my task completed, or when is my task submitted? So you can assign listeners for that. A use case, why is it relevant to me? Well, the concurrency that is supported in Java EE today is for container tasks. I want to do this for my user tasks. I'm a user, I have a task that I want to run, and I want to run it concurrently. How do I do that? Today, that's not possible. That's not permitted. So let's say I have my business logic here that I want to put it into a run method as implements runnable. So if you want to remove the word manage from here. If you want to do executor service and say I'm going to create my thread pool automatically, not allowed. But now with Java EE 7, you can say I want to create a managed executor service, and I'm going to run my task here. In here, if you do any JNDI, if you do initial context and say load an object, or you do add inject persistence context, things like that, those would automatically work because this is running in the context of your entire application. So all that functionality is available, which was available for container is now available for your user tasks. That's your use case typically here. Batch and concurrency are my 4 new JSRs that are part of the platform. Let's take a look at some other JSRs where we have made huge improvements. Jax-Rs, I have a session on that starting at about 2:10, I believe, in Hall C, I think. Jax-Rs is a standard way of doing RESTful web services. In the versions so far, we were focusing primarily or focusing exclusively on how I can publish a POJO as a REST resource. That's a server-side thing only. Now, if I want to invoke that POJO, I have to use curl or Postman client or something like that. With Jax-Rs 2.0, we're introducing a brand new client API. This client API would let you invoke any REST endpoint using the predefined concepts which are actually available in the API already. So it's leveraging the existing concepts, existing terminology to invoke a REST endpoint very easily. And I'll show you a sample for that. We're also defining request and response processing extension hooks. So for example, you want to do logging of your messages, or you want to do gzipping and ungzipping of your messages. These are my extension points. They are not part of the specification. They are specific to your application, but you want a standard way, a portable way of enabling that. Those are my message filters and entity interceptors. And in my session, I'll cover that in more detail. Another thought process, another feature in Jax-Rs 2.0 is really we are not greedy in the sense if I know that my task is, or my resource or my client is going to be greedy in the sense it's going to keep accessing a resource or a database or reading something from a file system, then I don't want to hold on to the thread. I'm going to suspend the thread, and when I'm ready, that okay, I'm ready to return a response, I'm going to resume the thread back. So this is an explicit decision you have to make as part of your application design, but once you have made that decision, that makes your application much more scalable. So your thread comes in, you receive a request, you park the thread while you're working on it on a worker thread in a separate one, and once your response is ready, you resume it and then send the response back to the client. Both client and server are independently asynchronous, or they could be synchronized as well. And we have some common configuration elements. Let's take a look at Java API for RESTful web services and the client API. Now, today, if you want to invoke a REST endpoint, you have to use HTTP URL connection. So there's a lot of boilerplate code. You have to set the metadata, set up a connection, and then handcraft the body, send the message payload, get the response back, figure out whether it's get, put, post, delete, and handle all the response and status codes, etc. This is a simplified way of invoking a REST endpoint. So here what I'm saying is, I have a client builder. To the client builder, I'm saying, Mr. Client Builder, give me a new client. Give me a new client instance. I get a client instance here. Once I get a new client instance, on the client, I can set a target to the endpoint. So this is my URI, which is the endpoint which I want to invoke. Now remember, in this URI, I can have a variable part of the URI, which is specified in curly parentheses. I could say resolve a template. This order ID, the value is 10. And then I'm saying query parameter, which is the value which goes after question mark, name equals value. I can specify query parameters here. Then I'm saying go build a request and fire a HTTP GET. Once I fire a HTTP GET, I want to get a string response back, and I get a string back here. Simplified version, Fluent Builder API, very rich API. There are a lot of variations possible in it. Come to my session to learn all about them. Or 1.1 was almost 10 years ago, long back. This is like when we had JDK 1.4. Anybody still using JDK 1.4? Wow, hats off, man, hats off. Still using JDK 1.4. Yeah, let's talk afterwards. Why are you using JDK 1.4? I'm sure it's customer driven, but I understand the pain. The key point that I want to highlight here is there's a lot of catch up that we need to do as part of the JMS 2.0 specification. The language from JDK 1.4 or Java SE 1.4 has evolved so much. Generics, annotation, try with resources, auto closable, so many new functionality is a part of the platform. So JMS is mostly playing a catch up. The main focus being what we call the JMS 1.1 classic API to introduce a simplified API, a modern API. We're going to reduce the boilerplate code over there, heavily using dependency injection. And this API is, of course, available both in Java EE and SE. So let's take a look. Well, this is the code that you need to write to send a message using JMS 1.1. Don't try to read the code. The font is intentionally small. But the problem with the code here is I have to create application server specific resources or application server specific. Then I am writing a lot of boilerplate code. Now, this is not good because my intent is to send a message. But to send a message, I have to write 5 lines of code. That is ridiculous. And I'm creating a connection factory. From there, I get a connection. Then there, I create a session. From there, I create a producer. From there, I create a text message. It's ugly. It's sheer ugly. I mean, well, it did its purpose. It did very well when the API was designed. That's the knowledge we had at that point of time. But now it definitely looks very ugly. So we're going to clean up that code. And then finally, in the bottom, you're seeing a lot of exception handling happening. Why can't you figure out, connection is out of scope, so automatically take care of closing it? Why do I have to do exception handling? I'm a lazy programmer. You do the job for me. 2.0. That code, about 20 lines of code, cuts down to this only. So let's read this code. Then what I'm doing is at inject JMS context. JMS context is my new object, which is a simplified API object, which is an encapsulation over connection and session. I'm saying I don't want to deal with connection, session, all that crap. Just give me JMS context. One thing missing over here is a connection factory. That is why is that missing? Because I've introduced a new default JMS connection factory. If you do not specify a connection factory, we automatically inject that for you. So that's how we take care of application server specific resources. This is again specific. This is a global JNDI name, portable one. This is my destination. And in the send message, I'm saying from the context, create a producer, send a message to this queue, and that's the payload. Now, not only is this code much more maintainable, but it also improves the semantic readability of your code. You no longer have to comment your code. How many times, think about this, if developer, if a new developer comes on the team, if he has to inherit this code or this code, which one would he be happier to inherit? Well, I would be happier to inherit this code, not the earlier one. In the earlier one, I would expect like a few comments like, why am I doing this? What is the purpose of this parameter? Why am I doing so much boilerplate code? So that's sort of the whole idea of cutting down boilerplate code, making it a lot more effective. Less is more, what I say. In terms of bean validation, now bean validation was a new specification that was added in the Java EE 6 platform. It allows you to specify constraints, as we talked in the beginning, on POJOs, which can then be honored by different layers. As the first version, we provide integration with JSF and JPA, how you can put the annotation constraints on a JSF backing bean, and the data is automatically validated for you. Similarly, for JPA entity, you can specify the validation constraint, and then the data is automatically validated for you. So if you try to persist a JPA entity and the constraints are not met, there is a violation thrown, which you have to handle. If you won't throw a violation, or if you won't put the validation constraint, then the database will throw an error. It depends what layer of the stack you're putting the constraint, and then the error is thrown accordingly. The deeper it is, the costlier the message is. As part of Java EE 7, the main changes that are coming over there is, now I'm no longer restricted to JSF, JPA, and things like that. I can put that on any POJO object. So, for example, here I have a POJO on which I'm saying public void place order. I don't want the product name to be null. This quantity is an integer, and in that integer, I don't want it to be null, first of all, and I want the maximum quantity to be 10. So those are the constraints that I'm putting in. Now, not null and max, these are my predefined constraints. I can also define a custom constraint. I could connect my database and do some custom validation very easily. The custom constraints are part of bean validation 1.0, but now I can put them on a POJO. What happens is, if this method is called and the constraints are not met, a violation exception is thrown. That means the method is never invoked. Think of it like that. Similarly, in this method, I'm putting at future. All that means is, I'm getting an appointment if the date has to be in future. If by mistake, this method is returning a date that is either current or past, then think of the method as if it's never being invoked. Instead, it will throw a violation exception, which you have to catch and handle accordingly. So the idea is, once again, just like JMS, this is improving the semantic readability of your code. You're no longer saying in your method parameter, imagine your code without the red code over here, then here you'll have to say if product name equals not equals null, if this, that. That's ugly code. You want to put the annotation, let somebody else do the job for you. You can sit back in a chair. Bunch of functionality. The one that I'm excited about is the schema generation properties on how you can bundle your DDL or description language and DML, data manipulation language scripts, as part of your WAR file or access them from a URL and say, you know what, when you're deploying the application, automatically generate my database using these scripts. Automatically populate the database with my scripts. Once again, this functionality is primarily focused towards rapid prototyping. You don't want to do that during deployments. During deployments, you typically have a DBA team who does not like a developer and developer who does not like a DBA. They work in total isolation most of the times. We also have this concept of unsynchronized persistence context. In terms of unsynchronized persistence context, typically the persistence contexts are synchronized. By synchronized means whenever you make a change to the persistence context and it is in a transaction, it will automatically write to the underlying data store. Unsynchronized persistence context is a useful concept, specifically with mobile applications and things like that. You lose the network connectivity, doesn't matter. I'm an unsynchronized persistence context. If you don't have connectivity and you are a synchronized persistence context, it will throw an error. But if you're unsynchronized persistence context, then you can say, never mind, I'm making changes to the local persistence context. Whenever I am connected or whenever I'm explicitly joining a transaction, that's the point I'm going to write the data to the underlying data store. We also have access to user-defined functions and stored procedure queries as part of your database. In Servlet 3.1, we're adding a few features. First one is the non-blocking I/O, and I'll talk about that using code. We are also adding the ability to do HTTP protocol upgrade. That's how WebSockets are upgraded from HTTP to WebSocket. One particular security enhancement, which I think is pretty cool, is deny uncovered HTTP methods. Now, in your web XML, if you don't have a method that is explicitly covered by security, that's called as uncovered security method. So, for example, if your web XML has HTTP GET and you have a security constraint for that, that's okay. But HTTP POST is uncovered. That means anybody can invoke HTTP POST. That's the default thing. Here, what I'm saying is, just by adding the annotation called as deny uncovered HTTP methods, I'm restricting any methods that are uncovered, making my application much more secure. That means I have to explicitly define what each and every get, put, post, delete, those methods, what are the security constraints around that. Let's take a look at the non-blocking sample. So here, for example, I have a servlet, do get method. Traditionally, if I'm doing an input output from the servlet or reading the value from a servlet, this is a blocking read. I'm saying while length is input.read, I keep reading till it's -1. With non-blocking, what I'm going to do is, in an asynchronous servlet, I'll just set up a read listener. Just simple suspend resume pattern. I'm going to say, I'm going to set up a read listener. Whenever the data is available, this read listener will be called and I will read the data. So I set up a read listener, and whenever data is available, on data available method is called and I read the data. So it's very simple suspend resume pattern, but once again, it's a non-greedy pattern. So your applications become much more scalable that way. JSF 2.2, which is the version that is as part of Java EE 7. A few big ticket items over there. The first one being a Faces flow. Now, what is a flow? Think of the flow as a shopping cart. In shopping cart, you typically have a shopping cart page, a credit card page, an address page, a checkout page, things like that. Now, those are logically related page. You may want to bundle them together as a module and reuse as part of your other applications. Today, that's not possible, or at least there is no standard way of doing that. With Faces flow, this concept has been available in my Faces actually for a very long time. In ADF Faces, this concept has been available. So you can actually have a concept of a flow. You can have nested flows, one flow with another flow. You can pass parameters between different flows. we are defining new expression language or EL expressions, which would let you check the value of the flow. So all that is possible. We're also defining resource library contracts. This resource library contract allows you to create a look and feel or a pluggable look and feel for your application. Again, as a reusable module, you can say, let's say you are a corporate, you create a resource library contract as a jar file. Say, bundle this jar file in all your applications and you will have a consistent look and feel as defined in this jar file. Things like that would be very much possible. This feature is particularly very exciting. Now, up until now, one of the things that was not possible was if you want to do transactions, well, you can do, of course, user-managed transactions. You can say inject a user transaction and then do commit, rollback, all that stuff. But now, what we have done is, as part of JTA 1.2, we have extracted the transactional semantics. That is, you can put @transactional annotation on any bean object. Not just EJBs. EJBs is the way to do container managed transactions, but now you can put @transactional on any bean object or any bean, either on a class or on a method, and then that particular class or method becomes transactional accordingly. And we have all the semantics like required, requires new, mandatory, never, supports. The typical EJB semantics are available to a much wider set of POJOs now. Similarly, we have introduced a new scope called as transaction scoped. So these are the beans. If you put the scope on a POJO, then those beans are automatically activated and passivated depending upon whether they're in a transaction or not in a transaction. Talked about, as I said, they're all final. That means the specification is final. The implementations are almost final and integrated as part of Glassfish 4. You can download them, or you can go to glassfish.org and download it from there. Now, going forward, what we are looking at, in Java EE 8, how we can deliver a standards-based, PaaS-based, or a standards-based programming model for cloud. How you can build an application that can be deployed in a PaaS environment in a standards base. The several APIs we're looking at, how we can build a modular Java EE application, how we can do multi-tenancy, how we can have a NoSQL data store, and things like that. So those are the different aspects we're looking as part of Java EE 8. But Java EE 7 is not done yet, almost there, but not done yet. So I would say stay tuned for details on that. In terms of call to action, what I would request is, glassfish.org is my one URL that I want you to look at. Go to glassfish.org. That's where all the details about specifications, implementations, downloads, etc. are available. That should hopefully get started. And I'm going to I have a couple of minutes for questions, if any. Caching that could not make it into the Java EE 7 platform because of time constraints. Now, if we start backtracking, typically a spec has to be semi-ready at least 4 months before it goes final. And the caching spec could not make it in time for the Java EE 7 spec, but that's one of the targets for Java EE 8. JCache is primarily about distributed cache, but there's another API, data grid, which is JSR 347, which will build on top of JSR 107. I can't hear anything. No, those are two separate specs, 107 and 347. Yeah. Probably, well, the scope for EE 8 is not defined yet, so everything is a definite candidate. Yeah. The inbuilt timeout, and you can also configure that as part of your WebSocket connection. That how the timeout retries, which is a TCP layer protocol thing, you can configure that. Okay, thank you very much.